All right, so here we are, 8.2. I'm going to do some homework questions with you here. Again, we are solving systems of equations. We have linear and quadratic. We're going to solve here. So this one is not asking us to solve. It's actually giving us one of the answers, and it's asking us to verify that 5, 7 is a solution. So again, when you do an entire problem from start to finish, you should check your answers. And so this is a practice on how to check your answer. How do we verify? Well, if we've got x, y, or in this case, it looks like we'll go k and p, I guess. They're not really telling us that. But I guess k comes before p. So let's say that the 5 is k, I'm assuming. And the p is 7. So what we're going to do is we're going to plug these values in. So it's going to be, take a look at the first equation. That's 5 plus 7 equals 12. That's great. The second equation here, 4 times 5 squared minus 2 times 7 is 86. Okay, well, 4 times 25 minus 14 is 86. That's 100 minus 14 is 86. That appears to be true. 86 equals 86. So I have now verified. These are my checks. There's check 1 and there's check or verification 2. Any questions about that? All right, I'd like to do number 3 with you here, and this is, number 3 and I think number 4 are what I have planned here to go over with you. So we won't do all these, but again, solving the systems. That's the bottom line, the basic, the number one goal of this section is to solve a system. So we have different methods, and I'm going to start with letter A here. We'll do letter A. So we have different methods. We could do the elimination or substitution method. Now, a couple hints. If you have a variable that's already isolated, like all by itself on one side and positive, substitution might be your easiest route to go. If it's close to that, like, I could get y isolated pretty quick here, so you might want to do that. If you have a variable, and again, for the x squared and x and y, you're going to want to eliminate the y's, okay? Because you can't add these ones; they're unlike terms. So if you want to do elimination, you have to eliminate the y values. You can't eliminate one of the x's here because they don't mix, right? So what I'm going to do is I'm going to do substitution. I'm going to just change this second equation here into y equals negative 4x plus 14. I'm going to take the y over here to make it positive and the 4x over here to make it negative. And then what I'm going to do is I'm going to take this piece right here from the second equation and I'm going to put it in where I see y in the first equation. That's called substitution. And I'm going to make one equation, x squared minus, here's the y, negative 4x plus 14 plus 2 equals 0. So I've plugged this part right here into the first equation right here. Keep all the signs the same and everything. Now we'll simplify. X squared, that's going to be actually a minus a negative 4x is plus 4x. If I subtract a positive 14, that's minus 14. So that's important. Make sure you eliminate those brackets properly. And now I'll gather some like terms. I have a couple constants there. X squared plus 4x minus 12 equals 0. And it looks like I can factor this by sight, which is going to be amazing. And so this is going to be x here. And I can find two numbers that multiply to negative 12 and add to 4. That's going to be 6 and negative 2, looks like. So I'm going to go plus 6, and I'm going to go negative 2. Now, my x solutions for x, the possible solutions are going to be negative 6 from this factor and positive 2 from this factor over here, using the zero product principle. And so now, knowing that I have some kind of quadratic and linear system, I could have 0 solutions, I could have 1 solution, let's say, or I could have something like 2 solutions. And it looks like I may have 2 solutions because I've got negative 6 for an x value, and I've got positive 2 for an x value. So I just have to find the partner y values, and it looks like I may have 2 solutions. That's what the algebra is saying to us. So, all right, well, let's see. So now what I want to do is I want to plug negative 6 into one of the original equations to find the y value that goes with negative 6. And you can pick either equation. I'm going to pick the second one because I don't want to square anything. I'm lazy. So 4 times negative 6 equals 14 minus y. Well, I want to solve for y, so that's going to be negative 24 minus 14 equals negative y. That's going to be what? Negative 38 equals negative y, or y equals 38. Okay, does that look okay to you guys? Positive 38. Hopefully I did that correctly, all my mental math there. Okay, we'll double check this after, but so now we'll do the same thing to 2. Let's put it into, I don't care. Let's put it in the other equation, just to so we're not prejudiced against this first equation, I guess. 2 squared, what was it? Minus y plus 2 equals 0, right? Okay. So that's going to be 4 minus y plus 2 equals 0. 4 plus 2 is 6 equals 0. 6 equals y. Okay, so I put the y over here on this side, made it a positive. So y equals 6. So it looks like 2, 6. 2, 6, and negative 638. So you can check by plugging these points into each equation and making sure the left side equals the right side. Or you could graph this now. Again, we're practicing our solving by using algebra methods, but you could check by graphing. I like doing that. And Desmos is great for that too. So let's just plug these into Desmos and see what we get. Okay, so here I've graphed it on Desmos. Let's make this screen a bit bigger here and zoom back out. Okay, so there we go, quadratic and linear, and it looks like we have 2 intersection points. This first one here is, what is it? 2, 6. 2, 6. Let's see. Oh, 2, 6. Nice. That's this one down here. Let's check out the other one. It's going to be way up here. This one is negative 6, 38. Let's see. Oh, negative 6, 38. Sweet. So we've checked that graphically, and now we can be confident that these are the 2 points. These are the solutions. Let's go back and see what the question asks us just to be sure. Solve, verify. Okay, so to solve, we have 2 solutions. And again, if you have x and y in your question, in your equations, 2 variable equations, that means they're looking for points that include an x coordinate and a y coordinate. All right, not just an x solution, an x and a y. So we've got negative 638 is one solution, 2, 6 is our other solution. Any questions on that one? 3a? Yes, no, maybe so? No? Okay. Let's get some practice with elimination, because like I say, elimination I think tends to be the one that students struggle more with. I don't know. Plus, I think I just did a substitution there, right? This one was, I did substitution. Okay, so elimination. All right, so what I want to do is I want to try and get the like terms on the same side of the equation, which they already are. So look at this. I've got 2 quadratics. I've got x squared, x, y, and the constants, and the equal signs line up. So that's perfect. You want to get all the like terms on the same side of the equation sign for both equations first. Now I'm looking at these and I'm saying, boy, I got a lot of options here, man. I could multiply, you know what, if I multiplied this second equation by 3, that's what I'm looking at right now. You know why? Because I could eliminate the x. But then you say to yourself, gee, if I eliminate the x, I still have an x squared term and a y term. That's no good. Remember what we said before? You want to try and eliminate y if you can. Remember me saying that? So even though this looks easy to do, you have to focus on the y's. If you have x squareds and x's, you want to get rid of the y's because then you're going to end up with a quadratic, and we know how to solve quadratics. Okay, we'll be back to square one if we still have an x squared and an x and a y, and so you want to get down to one variable. So in that case, I think I'm going to multiply this one by -2 because that will make this into a, so it'd be -4x squared minus 2x equals -2y plus 8 if I multiply everything by 2, right? So it's negative, 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 positive. Okay. So now I'm just going to stroke this out, get rid of it, and I want you to see that, do you see how this y term and this y term will now cancel each other out totally? So I'm going to add those. 6 minus 4 is 2. x squareds. Negative 3 plus negative 2 is negative 5x equals, the y's are completely gone. That's awesome. Negative 5 plus 8 is plus 3 on this side. All right, so we look like we got a quadratic. We need to do this, 2x squared minus 5x minus 3 equals 0. We need to have that equals 0 there. And do you know what? I think we could factor this one. I think we can factor this one. Let's give it a try. 2x and x. You could use quadratic formula as well, no problem. But I think if I do a 3 over here and a 1 here, I'm going to have 6x and 1x. And I could get a negative 5, I think, right? 6 and 1. So let's see. If I did negative 6, so 2 times 3 is negative 6, plus 1, that's going to give me a negative 5 when I add those up. And 1 times negative 3 gives me a negative 3. So, once again, if you're having problems with elimination, substitution, go back to Foundations of Math 10 videos, watch 7.4, 7.5. If you're having trouble with factoring, trinomials, I have lots of videos in all sorts of different math courses that deal with that. Go look it up, okay? I'm not here to teach you about factoring trinomials, but we just have to use that. So you can go and look that up. I'll maybe try and give you the link to that later. But anyways, from here, now I've got two options, it seems. X equals, if I let this factor equal 0, it's going to be negative 1/2. That's what x is going to be to make this 0. Over here, x equals positive 3. So those are the two options for my x values. And now I have to try and find my partner y values. So I need to find the y that goes along with this one and the y that goes along with this one. So again, I want to use my original equations just in case I messed up here somewhere in my work. I want to use my original equations to try and do this. So let's try 6 times negative 1/2 squared minus 3 times 1/2 equals 2y minus 5.
Could all high school SLC please go to the student?
So this is 6 over 4 minus 3 over 2 equals 2y minus 5. And again, so I'm just going to go this pretty quick here. This is going to be 6 over 4. Oh, okay. So 6 over 4 minus 6 over 4. That's going to be easy. So this is going to be 0 equals 2y minus 5. 5 equals 2y. Y equals 5 over 2. So it looks like y equals 1/2 and y equals 5 over 2 go together. Again, we're going to check this at the end, so maybe we messed up here, but let's keep going for now. And then let's check out x equals 3 here now in the same question. X equals 3 and solve for y. So what's this? 6 times 9, that's 54 minus 9. And I'm going to bring this over. Plus 5 equals 2y. So that's 45 plus 5 is 50 equals 2y. Y is 25. Okay, now again, if you get to this point, right, now you have to verify. You have to check. Put these numbers into each of these equations. Check if the left side equals the right side. Or graph and check. That's okay too. I like graphing and checking. It's easy to do. So let's check Desmos here.